So, добрый день. Hello everyone. It's okay pronunciation. Well, my talk called SCADA Deep Insight Protocols and Security Mechanisms. So let me introduce myself. I'm penetration tester at Positive Technologies security company. Also, I'm SCADA security researcher, and my main specialization it's industrial protocols. Also, I'm SCADA Strangelove team member. SCADA Strangelove team, it's a group of security researchers of SCADA software, protocols, and devices, and so on. I'm made talks at Positive Hack Days and Power of Community, and made a workshop at previous Chaos Communication Congress. And here's you can see my contacts. Feel free to stay in touch. Well, I forgot. I'm from this country, as you can see, and here is a not a stereotype. It's a typical day. Well, what I'm going to talk about in my presentation, I will give you a few words, a short overview of what is SCADA, SCADA world. I give you a short what's current situation in industrial control system network security. I'll give you a brief overview of industrial protocols, and shortly a few words about most popular and well-known and well-described on another talks protocols like Profinet, Modbus, and MP3, and give you a little overview of more particular protocols like MMS and IEC 101, 104. Also give you some information about Honeywell technology called fault-tolerant Ethernet, and most part of my presentation describe Siemens products, Siemens vulnerabilities, and some 0 days, and Siemens proprietary 7 protocol. And the final part I'll show you, if I had enough, will have enough time, my approach to analyze proprietary protocol. And well, I think we should start. 10 minutes ago I decided to skip this part to discuss what is SCADA. I think most of you, all of you know what is SCADA, what is ICS. So let's switch this type. But a few words about it. Industrial control system covers all of our life. It's very critical and very widely covers our life, as I said. So it's everywhere, for example, in power systems and water industry and automobile industry and your brewery and so on. Here you can see my favorite device that I'm trying to reverse. It's a programmable logical controller, Siemens S7. Here it is. Well, a lot of vendors in the world that provide their own decisions, own products for automatization, but most of them, like Siemens, Advantage, Codesys, Moxa, and so on, and also some Chinese no-name vendors. And there are two main problems for creating ICS systems more secure. It's that, first of all, each vendor creates their own technology, own protocol, and another problem, it's most of the technologies was developed a lot of years ago, and they, for nowadays attack vectors, they are out of date. And its main approach, don't touch it if it works. So I think it's wild, I called it wild industrial world. So what about current situation? Let's if you think that ICS network looks like this, so it's absolutely unbreakable, you're wrong, because main problems in industrial control system networks, it's typical network devices with default and crappy settings. A lot of software and engineering workstations, they have junk software, very often malware, they all patched and altered as dirt. Sometimes you can find in production systems wireless access points with VIP encryption, but if the best happened. And typical situation, it's low security, low physical security, and final part, so it's industrial control, industrial protocols. So we will talk about protocols. So how protocols live in a network? First of all, they full expanse and not blocked by firewalls and switches. Protocols accessible from all segments, they're accessible between LAN segments and works from data link layer to application link layer. It depends of transport system which used by protocol, and of course it's easy to detect and easy to intercept, analyze, reproduce and reply, but not at all. Well, I said you about a lot of vendors provided their protocols, so but very used and widely spread protocols, it's Modbus, Profibus, Profinet, and so on. Here, for example, so let's go to talk about Modbus. It's very popular and well-described protocol, so I don't want to waste time for this. So it's published by Modicon about 35 years ago. Modicon now acquired by Schneider Electric. Modbus mostly widely used for connection between industrial devices. Previously, Modbus used serial interfaces, but then switched to TCP stack protocol, and now it's standard port. TCP port for Modbus is 542. Well, which functions provides Modbus? It's simple data access, it read-write coils, registers, and file records. Also, with Modbus, we can identify devices on the network, and some vendors create their own user-defined functions. For example, you can see Modbus user-defined function. It's a T-Shark dissector. Which tools we can use for Modbus and playing with Modbus if you don't have a real device? A lot of simulators. Also, we have Modbus Discover and Map Engine script and tools like PLC scan to discover devices on the network. What about security in Modbus? So I just want to say it's no authentication, encryption, and finally, as a result, no security. So I think I can skip protocol headers. It's obvious and easy to understand. So another protocol is DNP3. DNP, in short of distribute network protocol. So its first release was 24 years ago, but it's standardized by International Commission in only 4 years ago. So the DNP3 used mainly in water and electric industry, and it's master's outstation communication. So on the stack of TCP and UDP, it uses standard port 20,000. So also it has tools like Wireshark dissector and free implementation of the DNP3 library. What about security? We have only the DNP3 secure authentication standard that was first released 7 years ago. But in real life, it's not implemented and not, just want to say it's not secured. The DNP3 secure authentication provides us device and user authentication and data protection. Here you can see just simple, it's okay? Okay. Simple packet structure of the MP3 frame. Just want to say that the MP3 works on layers data transport and application. Well, another one protocol is Profinet. It's a family of protocols, but I want to say about DCP. It's short discovery and basic configuration protocol. It works on second layer of network model and has RUNET type 4492. Profinet DCP exchanges data in real-time cycles and has possibility to send multicast discovery request to identify devices and stations. So the same about security, no encryption, authentication, and no security as a result, but it's obvious because it works on second layer. So here you can see simple Profinet DCP traffic dump and which frame types on DCP stack. It has three frame types: request, response, and get and set. And you can see on the slide two strings of SCADA code that send multicast identifier request. Brief overview of payload DCP. So from up to down it's request, then next service identifier and request, then exceed, it's like a request ID, but really it doesn't matter. So next it's delay, it's time for which time we wait in response from devices, data length, and which options we want to ask from devices. So here you can see, okay. Well, main interesting fields for playing is option and sub-option. We have list of options that provides by Profinet DCP, and we have reserved functions and sub-functions which can implement each vendor for their own decision. For example, set get and network information. We have options and sub-options 1 and 2. And for example, if you want to send LED flashing, which means that something wrong with the device, we can just send option 5 and sub-option 3. So we can scan Profinet supported devices and stations. We can change name of station, change network settings, which really critical. And we can request full network information and LED flashing. Well, I wrote Profinet DCP scanner. It's based on raw sockets and also on SCADA. It's Profinet scanner. Here you can see example of scanning internal network. It finds a lot of devices that provides support of Profinet DCP. Well, I just want to show you maybe the next slide. I show you how to scan devices and how to make device, how to get device in defect mode. So also I wrote Profinet fuzzer, which fuzz options and sub-options on PLC controller. And as a result, I found a 0-day that which means that attacker could cause the device to go to defect mode with specially crafted Profinet packets. What is defect mode? It's really, in terms of Siemens, it's like something wrong with controller or something, and should we restart controller. So what is specially crafted Profinet packets? So it's just set request, set network information to all zeros, and you will give your device into defect mode. So I want to show you how it works. Oh, it's okay. Well, just a little bit smaller. Yep. Done. Profinet scanner. No SCADA. Well, just one option. You should give script which interface you want to use. So, and well, we got DCP answer. We parsed it and got some information about device, which here you can see that it's controller, it's a master device, and you got network information. Well, let's go deeper and send just a second. It's our Python Profinet set network info. So interface. So we should give script destination MAC address because it works on second layer. We should give script source MAC address. Just a second. I can hear very well, but okay. Okay, so now Profinet controller, sorry, in normal working mode. IP address. Okay. Network mask 0, 0, 0, 0. A lot of zeros. And gateway 0, 0, 0. Yep. Okay. Send. Oh. So LED flashing blinks, and from operator station or HMI, it looks like connection aborted with controller, and we should make a cold restart of the device. For industrial control systems, for automation processes, it's really critical. Let's switch to our. Okay, so let's continue. So, brief overview, short words about two protocols like MMS. MMS, it's manufacturer message specification, but it's not only protocol, it's specification to create all your own protocols. So it's very old, and use ISO-TSAP as a transport and standard TCP port 102. So with MMS messages, we can read-write text, variables, and domains. Domains, it's large part of unstructured data. For example, program coder. And with MMS, we can start, stop, and rewrite firmware on PLC, and read, write, and delete files and directories. Few words about security. It's just simple methods whitelist, and it's trying to implement TLC on MMS, but it's only in theory. In my practice, I don't see devices which supports TLC. Well, toolkit, it's like Wireshark dissector, and I wrote Python and nmap identify scripts. And also you have a lot of emulators. If you want to play with MMS protocol, just Google it. So, it's wrong. Here's a simple example of how to find with nmap devices that support MMS. Another protocol, it's IC 101, 104. Difference between them, but only that 104 uses TCP stack. I see these protocols mainly used for gathering telemetry and so information in electricity distribution and power system automation. But this stack of protocols have a huge list, which main read-write text, upload, download files, and so on. So security, it's no authentication, no encryption, and simple IP address whitelist. IP of master device defined on slaves, but in this point we can use just ARP spoofing. And standard port TCP 2404 and toolkit and Warshak dissector. As for previous protocols, and also I wrote Python and map identify scripts. Here you can see how it works. You can find your own devices on the internet, but don't try it because it's illegal. So what about FTE? It's a proprietary technology with their own implemented protocol, fault-tolerant Ethernet. This technology provides a robust and low-cost technology for industrial networks. And main idea that each node connected twice to network and support actual route to table between devices and stations, and each period of time, for example 1 second, each node exchange route table with other nodes through multicast request. FTE use UDP as a transport, and from my practical way it was released fluid UDP ports and sent multicast packets with fake routing table. You can just send all traffic, all data that exchange devices through your controlled workstation. Well, it's example of traffic. Well, just a second. A big part of my talk describe Siemens and Siemens S7 technology and some features in SCADA software called TIA Portal. TIA, it's an intellectual kernel of more than 100,000 products created last 15 years. So what's about users, passwords and permissions? Here looks like you can see a typical interface of TIA Portal, where you can create protection from read-write of PLC for main critical operations like CPU start-stop, data change and project upload and firmware update project. In terms of Siemens software, it's kind of file which realize automation logic on controller. Project file you can upload to PLC. Well, what about project file? It's p-data PLF, and interesting thing that when you change password through TIA Portal, previous password saves in PLF file. Moreover, passwords hashed with SH1 hashing algorithm, and another helpful byte we can see that redbox value, it's just simply password len multiple 2 plus 1. So I don't know why they use it. So when we sent notice to Siemens, they stranged user passwords and switched from SH1 to MD5. Strange situation. It's how looks like passwords from one of the previous release of TIA Portal. So I wrote a Python script that extract password hashes, extract all previous password hashes, and you can just brute force if you're interested in it. Another interesting thing that after password hash MD5, you can find 2 bytes which corresponds to user rights. For example, if you change 2 bytes to maximum values, FF, you will be super root admin, because you can read text, write text, which options not accessible through TL portal. So how looks like SCADA and PLC authentication scheme? It's simply challenge response authentication. So I wrote Python scripts that extract challenge responses, export to John the Ripper format, and also Python scripts can simple brute force, but if it's hard password, long password, you can use John the Ripper. They released the module for brute force and Siemens passwords. So how it looks like from pickup file extracting challenge and responses. Also I wrote brute forcer to brute force controllers online. I released a module for well-known brute forcer TRC Hydra. So if you can, not so bad. Well, a few words about piece of code. Well, first interesting thing that all passwords maximum length 8, and if you have passwords not length of 8, they pad into 8 with spaces, and here's simple XOR encryption of password. Well, let's switch to another type of zero-day vulnerability that I found previous year, but CV timeline and patch release took a lot of time for Siemens. So main idea is that due to low entropy of random number generator from PLC, it affects to that you can get admin interface through web interface of controller. So here how looks simple web interface of PLC. So let's play a little bit with cookies. It's base 64 representation of cookies, so it's converted to hex representation. Somebody look interesting parts of hex. Maybe some very popular patterns and so on. Okay, so let's go deeper. Let's switch. Let's divide our cookie for 2 parts. First part and second part. And second part we divided. It's by practical way. So let's analyze what is going on here. Obviously, first part it was MD5 or something interesting. Second part it was constant value. Then next 2 bytes was a user logout counter and counter of issued cookies for these users. I just want to say that it was only one user. It's admin. Next value was, it doesn't matter for us, and next value was IP address of the client, and the last part of the cookie doesn't matter. So what about MD5? We did reverse of firmware Siemens and find out that MD5 it's next 26 bytes of cookie plus 16 bytes of some secret and 2 null bytes. So obviously, what is secret? Secret generates after when PLC start by a little bit harder than a standard C pseudo random number generator, and it uses some seed value at maximum 2 bytes. So here you can see piece of code of Python code that implemented random generator from a controller. So a lot of values we want to brute force because PLC is so tender. Well, what about seed? Seed very often depends on time value. Seed, as we get on practice, was PLC start time plus some time constant. It was secret generates after about 3-4 seconds after PLC start using current time. Well, how to obtain PLC start time? It's obvious because PLC start time, it's current time minus uptime. What about uptime? What about current time? You can obtain it through web interface, and uptime you can obtain from SNMP request with hard-coded into device read community string public. It's easy. So here's a Python code how to get seed range. Well, right now to generate cookie, we should brute force logout number, 2 bytes, number of issued cookies 2 bytes, and seed value 2 bytes, but only maximum 100. But it's still too many values to brute force. Well, what we're trying to realize to find a decision, and notice that if you not log it out properly after 7 logins, it's not possible to log in again to web interface. And right now we should restart PLC or wait 30 seconds, 30 minutes, it's cookie expire time. Well, we can minimize logout and issued cookies counters to 7. That's better. To generate cookie, we should brute force logout number, maximum 7 values, number of issued cookies 7 values, and seed value maximum 100. So as a result, I wrote POC for obtain real valid web cookies. Sorry. Well, I don't have a lot of time. So a few words about exploitation dependencies. You should have more than one success logins to PLC, because after logins, in memory of controller creates special tables of issued cookies. And of course, you should use SNMP enabled. But interesting part that it doesn't need login or password. So here you can see a CV timeline. For Siemens, it took about 1 year. A few words about the 7 protocol. It's previous versions of protocol well known. It has Wireshark dissector, some free library tools, and so on, and good materials about attacking the 7 protocols by Dylan Beresford. But last version of S7 protocols, we don't know a lot about it, but just want to say we know nothing about it. Well, how protocol stack works? It's based on ISO TCP. It means that this protocol block oriented. Each block is PDU, protocol data unit. And it means that functions and commands protocol oriented. It means that each frame contains function, request, and reply to it. A few interesting functions that provides and commands a 7 protocol. It start, stop CPU, firmware update, read, write data, and so on. Here how looks protocol stack a little bit. So as I said, we have for old versions dissector, libraries, simulators. So I decided, oh, it's not very well. Well, I decided to reverse a 7 protocol, and which approach I choose. I think this guy should know. Rob Savoy's on conference forced them. I said, believe it or not, if you stay at hex dumps long enough, you start to see the patterns. Well, I don't have a lot of time, but a few words about toolkit. I wrote 3 Python script that extract from pickups files payloads, trying to find and visualize some bytes which are you interested in it, try and find interesting byte sequences in payloads, and as a result a script called a 7-packet structure trying to reconstruct protocol stack. Well, I'm still on the way to reverse a 7 protocol. If somebody have useful and helpful for me information, please. Okay. Well, last words about why you should use your knowledge about protocols, but it's universal and complex approach from attacker's side. With your knowledge about protocols, both of open source and proprietary, you can detect devices and their protocols, you can monitor state, commands, exchanging data, and so on, because most of them are unsecured by design. Well, it's a real example from my pen test in practical. On some industry, we did a pen test, and if you want to change speed of energetic turbine, you can simply send UDP packets that set speed to turbine to 57. Well, it's easier than give the cat a stroke. So what will happen if you send another packet, another value to turbine? Yes, you write something like this. And finally, I share all scripts, all tools that I develop on GitHub. Feel free to use it, but don't use it on real systems, real devices. So a little bit later, I will share all pickups that from all protocols that I used to research after some cleaning. Well, I think I don't have enough time. Yeah. Well, thank you all of you, and greets to my colleagues from Positive Technologies.